No problem. So like I said, today we're presenting on behalf of Trimble, and I work for Allterra Central. I'm the Director of Research and Innovation. Rusty is joining us today on behalf of Halff and Associates. He is the team geospatial leader for Halff and Associates. He's got 16 years of experience in the geospatial services. He's an FAA remote pilot, Autodesk certified instructor, and you saw all of his software proficiencies there. But the title of our presentation is Mobile LiDAR, We've Got You Covered. You know, we're going to jump into the mobile LiDAR side of it, and we're definitely going to take a deep dive into that. But we also wanted to take a quick look at on the photogrammetry side and, you know, terrestrial scanning as well before we jump into the mobile LiDAR side. And we'll kind of pick up on those questions or hit those questions you had in the beginning there, Gavin. I think those will come up during the presentation. Let you take it away there, Rusty.
Thanks, Billy. Yeah, great presentation. I got to catch the one before, and so much of what I'm going to talk about parallels that. We are going to focus specifically on mobile LiDAR, but you know, we are tasked at Halff and the folks that Trimble and Allterra work with. A lot of them are tasked now to build complete point cloud data sets, and so although we're going to focus on mobile and that's our primary area of emphasis, we have to do manned aerial acquisition, drone aerial acquisition, and terrestrial to build that holistic, complete point cloud data set that many of our clients are asking for. They're underside of bridges or behind a construction zone, things like that. We have to use other tools as well. So I'm not going to do a deep dive here, but basics of manned aircraft and photogrammetry, many of you know. In fact, I love that some of these previous presentations are hitting on them. A lot of overlap on imagery, obviously. So both manned photogrammetry and LiDAR, I'm showing you here. LiDAR obviously helping us with vegetation, as the previous presenter talked about, and I'll hit into that more in depth when we talk about angle of incident. So we have a whole slew of drones, some LiDAR based, some photogrammetric. We do not own aircrafts. We sub that work out here at Halff, but we utilize them on many projects when it makes sense. You know, we all know the discussion of the right tool out of the toolbox. Again, just wanted to pepper you with, we have to understand doing the top-down collection as it fits the project. We like using the drone LiDAR a lot because we feel we can efficiently and safely get out. There are times where, you know, maybe the mobile LiDAR, based on the elevations of the road and where the ditch elevations are, we like the ability to take the drone LiDAR out in the back of the mobile LiDAR vehicle and do some additional acquisition, low and slow, and kind of getting down into vegetated areas with the drone LiDAR to supplement our heavy mobile data set. And so again, I wanted to pepper you. Here's just an example of a 350 acre South Texas campus. This is a photogrammetric model, but it's a point cloud, which many of you know well. But this was acquired in 1 day in the field, 350 acres roughly. So a lot of benefits to the aerial usage. Just again, a quick look at some of those. And so I'm going to show you some projects towards the end of the presentation where we're doing a hybrid data collection where we're utilizing terrestrial data, drone data, and the bulk of the work is our mobile acquisition, and we're tying it all together. So obviously there's reasons why you would use terrestrial scanning, whether it's the inside of a facility but if we're focused on assets and and topography, as I mentioned earlier, the underside of bridges, the backside of what we'll call undrivable areas, like in an urban downtown situation. We're even doing culvert scanning whenever it makes sense. The example I just showed you. So here's just a quick example of one of our terrestrial point clouds. Uh, it's interesting for me when we think of the term I kept chewing on assets, like what are assets, and I think there's a lot that applies there. So, but I'm gonna focus mostly on corridor type assets, but I wanted to just show a quick little fly through of a terrestrial scan and level of detail that, as many of you know, you're gonna get from one of them. As we move on out of terrestrial scanning and into the bulk of the presentation, mobile LiDAR. And I won't spend much time in bathymetric, but I just wanted to show, that's also another method of acquisition that we are expected to add into our topographic DTMs that we create. And none of this is possible without our survey friends. I am a part of the survey group here at Halff. We have about 100 surveyors across the company. We work with Southern United States. We have offices all over the Southern United States, and we focus on making sure our field guys understand geospatial acquisition, and so that when they're out there, the initial time, they can be paying attention to obscure areas and be thinking about good areas for ground truthing. The previous presentation did a great job of showing those accuracy reports. Often in Oklahoma, we call them OSSDA check shots, but that was derived from NSSDA check shots that ASPERS points us to, and we try to put a focus on that with our projects and validating our data, much like you saw just previously in the last presentation. So as we focus down into our mobile mapper, the Trimble MX9, which we purchased not too long ago. At my previous company, I had a different mobile mapper and did a lot of homework and really tried to focus in on getting one that brings us value in a lot of different ways. And one of my favorite things, and as I talk to my former coworkers, I tease them about one of my favorite things about the mobile mapper, the Trimble's MX9, is its flexibility and that we can put it on different types of vehicles. I don't have examples of putting it on a boat or a golf cart in here, but they're out there if you guys search for them. So again, easy to install. It's just it's a great system, very compact and very flexible for us. It's got the Regal units on it. We have the top of the line of Planet's AP60 on it. So we're using Pause Pack for our trajectories, and we also have the GAMS and DMI that we feel bring tremendous value in when necessary in areas of poor solution GNSS solution concerns, be it urban canyons or rural areas with tall vegetation or things like that. So as I said, very compact. Most of the information that actually pretty much everything on the system is what you're seeing here. You're seeing that iPad there on the left. It can be a laptop or different things, but we typically have a dedicated iPad that we use. You're getting a lot of real-time feedback. The Ladybug camera, which I'm going to emphasize here in a little bit, which is fairly common for mobile mappers, is a part of the system, and you're getting imagery real-time as well as your sky plots and all your GNSS solutions, so you can feel confident that you've prepared your IMU for acquisition prior to data collection. Kind of that smart driving wake up thought that so many mobile mappers and even drone acquisition and aerial acquisition, kind of our focus. Uh, not I would say about 50-50 on how many of the mobile mappers are going to do this butterfly pattern, but there are many that are out there that aren't doing it. In fact, we have an older, more smaller system that's a single sensor, which you'll see a picture of here in a second, which is not doing the butterfly pattern. And there's a lot of value in getting that, as I kind of think of it as an X driving down the road behind your mobile mapper, getting a wake like behind a boat. And it saves a tremendous amount of time as far as data shadowing goes, whether there's, as you're seeing here, vehicles blocking or other obstructions. So a lot of value in the X pattern. So here's an example of if your sensor was not in that butterfly formation, how you're going to acquire data, and just a lot more shadowing going on there, a lot more challenges. Typically takes quite a bit longer to acquire as I said at the initial presentation, a full data set without holes in it. So I mentioned the DMI and GAMS briefly, but they are working in collaboration with the IMU INS system to inform the system of in areas of outage or poor solution to help correct the data sets. So the IMU is helping in a lot of ways. I like to tell maybe inexperienced folks that the IMU is correcting as the vehicle's jostling and moving around. So think as you're going around this NASCAR bank at 70 miles an hour, well, the IMU is helping the system correct that data in real time so that you get a data set that, there's a lot of discussion on without survey control, which the last presentation just drove home control, and we're surveyors. That's where we're at too. Very, very, very critical, and we typically don't do a job without survey control. But for the GIS folks that are on here, you're gonna get, especially with good solution with this system, you're gonna get data sets, raw data sets, let's call it, because of all this equipment that's on here. Within a couple of tenths, you're going to be 1500ths to 2/10ths, somewhere in there, a raw data set if you've done all the proper steps. And then in areas where you get poor solution, you can start to slide out of that. But the DMI and the GAMS are going to do a lot to hold through if you pass through tunnels. Obviously, you still have to have control in these areas, but all these systems together build us out a raw data set that's almost ready. And then oftentimes our survey control is just some finite adjustments to lock it down. So there at the top in the right, you're seeing the Ladybug camera. But before I move on, the rocket launchers you're seeing right here, there's one here and one on the other side. Those are the two Regals. They have caps on them right there, so you're not seeing the glass and the laser in there. But so the Ladybug camera, we're a big fan of. So the MX9 has more than that. It also has additional cameras, like one in the back, which is a downward facing pavement camera looking at cracking and things like that. But my colleague who put this video together, he likes to show it in this manner, and he also shows it in this way. I don't think in this way. I like the Google Earth Street View where it's the spherical globe. So the Ladybug camera is doing that as well, and that's how I like to digest the imagery. But so one of our favorite things, actually our clients' favorite things, the engineers, is that not only can we provide this topography, the CAD deliverable that you're used to, we can even give them the full-blown point cloud, but they love the mobile mappers current good resolution, essentially Google Earth like street view imagery that they can dive into and kind of right out of the gate start doing that. In the Ladybug software that I just showed there, Ladybug Cat Pro is freeware, so we can we can give them the executable and give them the data, and they can dive right into a data set on their computer. So before I move on, this is the sensor, the other sensor I mentioned. We typically are using it on a drone, but we have a good setup where we can put it on the back of a vehicle too, where it makes sense, or like I say, a golf cart or an ATV backpack. And so it's a good Swiss Army knife sensor, but again, smaller sensor. IMU's not quite as good as what the MX9 is providing. And so the data sets aren't quite as pristine as what you're going to see from the MX9. So always like to show TRB's applications of mobile mapping because it's so vast. I love the pavement deformation. I've got to do several of those projects. I will show you briefly some of that. Obviously, all the asset extraction and things we're talking about, ADA compliance. So, you know, you drive an entire city and you can analyze all their ramps that were visible from driving and give them a GIS analysis of all of that. So a lot of applications. I suspect all of us on here know what a point cloud is, but just because I feel like it's the right thing to do, there's an example of one. You know, it's just millions and billions of survey points, and we can apply different view styles to it, so we can see things like intensity, or we can apply imagery to it to view it in an RGB style that makes sense to our eyes. But essentially, it's an ASCII file, an XYZ file, just like you would expect from a surveyor, just millions and millions of points. So just wanted to touch on survey control like our friends Compass did in the last presentation. We have a preferred method. With our mobile mapper, we really like the checkerboard like this, and we like to point it towards the road to where the tip of it is perpendicular to the road. It's not catastrophic if control's done in other ways, but we have tested it many ways, and Trimble as well, and we see the value in setting it up a particular way. So speaking of Trimble, some of these screenshots you're seeing in here are based on their experiences and opinion as well. So I've mixed that in as well. Some other methods, you know, just as we think about aerial acquisition on control, I always leave this slide in here. You know, table method often applies, so that's kind of what I'm showing you here. But focus on mobile mapping. Generally, if we feel we're having good solution, we'll stretch our control out 1,500 feet at times. But you know, common places we like to do a control point every 500 foot. Sometimes 1,000. It just depends on the circumstances of the project, but we're certainly always getting at least a check shot. That's what you're seeing here, those validation points every 500 foot. And it often makes sense to do what we call zipper method if it's a narrow enough corridor to where you don't have to set control on both sides, one across from the other. You can kind of zipper your control down the road like that. Because as we all know, a couple of things with control. Number one, it can be time consuming to some degree, you know, or what I mean to say is obviously we're trying to minimize the amount of time we have to put the boots on the ground and set that control. And for me, a big part of it is also safety. So if I know I can spread my control out more because the terrain and the project allows that, I'm going to do all I can to keep my surveyors off the side of a road as much as possible. So again, just another example of control layout. This one would be for large area mapping, but kind of table method. Photo IDs. Previous presenter I saw had some great photo ID examples, and we are a fan of that, both with aerial, drone, but also mobile mapping. So we try to use existing markings and other existing features when it makes sense on a project to minimize, again, the amount of effort on the roadside. So TBC has some wonderful control capabilities. I'm a huge fan of the ability to, because we have other software vendors with our other tools that don't quite have the flexibility that TBC does, as far as being able to look at your control point in 3 dimensions and overlay the imagery from the ladybug. So a lot of great functionality um, from TBC tying down our data sets. We, like the previous presenter, are big on validation. So this is just an example of steps that are built into our software that we use for our data extraction, that is giving us a few things. We can validate conventional ground truthing shots, GCP type, survey shots against the point cloud, like you're seeing here. We can also do it against the ultimate DTM, which to me is very important, because sometimes I fear that people validate their point cloud and they check that, but they don't validate their DTM at the end, and their DTM was not derived properly with enough proper break lines, and that's really, you need to be checking that. And when you find, and that's what the NSSDA check spreadsheet and process is all about. And so when you find bust in your DTM that don't meet your accuracy standards, it's not necessarily that your point cloud's bad, it's that your extraction folks did not derive enough break lines or enough detail to pass that. So quickly moving along here, data prep. We get tons of big corridors with mobile mapping, so we have to tile it properly, and we've got great tools to do that. Here's just an example of a 70-mile-an-hour data acquisition. I know some of these are hard to see through screenshots and things like that, but and then classifying the data. Here's an example of TBC's classification tools, and not only is TBC's software classifying it, but then it's going a step further, and it's like digitizing your assets. So here you're seeing trees being digitized, both location, height, and vegetative spread there into a GIS or CAD database. So just, I wanted to pepper you guys with some different types of asset extraction and analysis we do from mobile. This one had mobile, but also had a lot of terrestrial because of the need, because it's a structural analysis. So an example of bridge analysis for a DOT, analyzing the columns, deformation on the column, make sure there's no twisting. So here's an example of a mobile data set. So on the left, you're seeing top-down plan view, all the extraction CAD deliverable. You're seeing assets in there. And on your right, you're seeing the same data set as it moves through. And you can kind of see a green point of view here. So that matches what you're seeing in the camera. So this is about a 15-mile project, urban project. And but 15 miles in how, like, say, the engineer or the client may see it, but for the mobile collection, it was more like 75 miles of drive lanes, drive path acquisition on it. So when we think, so I'm going to kind of pepper you with extraction and asset and how we can utilize this mobile data to create whatever the end deliverable is for our clients. So here's an example of, with the MX9's high quality data set tied to survey control, we have extraction software capabilities that can use a template, and I'm gonna say semi-automatically extract the curb and the guardrail of this is like a mile-long bridge structure, and so there's just a lot of semi-automatic to automatic extraction that can be done with a mobile mapping data set that's done properly, and again has good sensors on it and has a good internal system, INS system producing a high quality point cloud for you. So what all can you use mobile LiDAR for? That's kind of what this is showing you again. This is kind of a slimmed down version of the TRB breakdown, but I'm going to show you some more examples here. So let's see if this video will play for us. So utility extraction is an example that I think I had on my previous screen. So with a high quality mobile mapping data set, we have the ability through our software. We utilize Topodot, MX9, Trimble, and Topodot have worked closely through the years, and we were already Topodot users, and so it made sense for us. That was another reason why we were excited about going with this mobile mapping solution. And so this is an example of one of Topodot's tools where you're obviously directing the power line for it. You're helping the software understand the direction of it, and then you're getting miles and miles of power lines acquisition done, so extraction. So moving on to the next example, I wanted to highlight the asset extraction portion of it. So think signs and power poles and things like that. So you bring in a high quality mobile mapping data set, you let the software analyze it, you give it some additional information, and tell it what type of cells, you have a cell template library, and it will chew through that mobile mapping data set and drop your CAD blocks for you. So we utilize a lot of these tools on our corridor jobs. Here's another example. Again, you've built a cell template, or for the AutoCAD users, a CAD block template, and you fed that into the software. And because you have a high quality mobile mapping data set, the software is able to analyze it and drop these blocks and digitize that for you. So here's an example of a project I'm going to show you here in a little bit of where we were able to use these semi-automatic tools to digitize all of our assets along the road. I'm not able to show you in this the pavement marking striping capabilities, but the one you just previously saw, it's very similar, where because the point cloud is such high quality, the intensity is easily managed by the software, and so you click and it traces your striping for you. So another thing we love about the MX9 is the accuracy of the data relative to itself is such at a precise and a dense model that the software I continue to show you is able to do pavement condition index analysis. So not only can it chew through the point cloud and analyze it, but it will build out GIS attribute tables that we have fed into GIS web maps, and you can hand over a municipality all of their roads, so that they can analyze it and understand the quality of their roads, and if they want to drill into a specific area for analysis, they can. I also wanted to showcase that, for our GIS people out there, these tools, this information will plug into Esri's software as well. So I'm not going to spend a lot of time on it, but that same concept of being able to use the ladybug imagery, it plugs into your ArcMap or your Esri tools, and our GIS folks can jump into there and extract assets as they see fit into a GIS platform. So you don't have to be necessarily a CAD user to ingest this mobile mapping information. So I wanted to just give our GIS folks a little bit of love there. And obviously, you know, if it is for GIS applications, sometimes survey control can be minimized very much. So I like to again talk about blending all these data sets together so that we can build a complete point cloud, and we can turn that in as a deliverable and feel confident that we have not left any holes. Sometimes there, you know, it's just so much vegetation that you have to fill that with conventional data, and we always use that when necessary. So here's an example of road data, drone data, road mobile LiDAR, um, uh, drone LiDAR, and bathymetric data all pulled into one. So why, again, why do you need to use it? There's a lot of reasons. As I was talking earlier, sometimes maybe with mobile mapping or with another method, the angle at which your sensor is going to hit, which I'll talk about here in a second, isn't quite where you want it to be. Vegetation could be an issue. Um, Safety for utility capture. I showed some of our utility extraction tools. Obviously, if we can keep people out of the road to do utility extraction, we want to do that. So as far as angle of incident goes, we're always thinking about the terrain. You know, you try and make that digital site visit before you do a data collection and understand the terrain and understand some issues that you might run into. So if it is a mobile job, you try and plan your driving properly to where you get good data sets. And as I said, sometimes it's necessary to utilize maybe drone LiDAR with it to fill in some areas that aren't able to be seen from the roadside. And then, like I said, the terrestrial we will utilize under bridges, or I'll show an example of a construction site here in a second. And then footprint, you know, so how, if we are doing an aerial acquisition, you know, how much overlap do we need? How big is the area? There's a lot of thoughts that go into manned aircraft versus drone acquisition, and how we want to collect that. And then, like I said, just general line of sight issues that you might run into. Here's an example of a construction site. This was, again, that 15-mile urban mobile mapping job, where we had a couple of construction zones. And so we used our terrestrial scanner and set up on the other side of that. And because we're using survey control properly and we have good acquisition tools, we can easily blend our point clouds and close any gaps. So you're seeing the blue here is the mobile mapping and the red is the terrestrial data set. And so we can extract a good CAD deliverable for the client. Vegetation is always a concern, and as I've said a couple of times. So one thing that's interesting for people to see is on the right. I'm not sure how clearly you guys can see it, but the green is photogrammetric point cloud, and the white, which is really hard to see, is a LiDAR point cloud. And this just represents like why, this is a cross section through some trees, and there's a little channel here. And so this is an example of why we use LiDAR and not photogrammetry all the time. And the green, those orange dots you're seeing there is our DTM grid and how we were able to use the LiDAR to derive that. And again, the utility capture side of it, safety first. It's a huge reason why you might use different types of acquisition and blend a hybrid data set. So here's a project example that I spoke to a couple times. Pretty huge mobile collection, but we also used drone information and we used terrestrial information. On this one, we didn't have to do any bathymetric stuff, didn't run into any of those issues. But so here's some examples of blending the ladybug imagery. You're seeing ladybug imagery and the CAD. that was derived from the point cloud, kind of blended together. And here's a top down where you're seeing the drone imagery that was utilized for different things. One of the uses for the drone imagery, because it's such high resolution, we were able to utilize it to pull out utility markings. And so using that in collaboration with conventional utility survey work and all the information you get from the utility providers, we were able to use the drone imagery to further extract our utility information. And I mean, anytime you can get high res drone imagery, most surveyors would love to have it. So we use that on the corridor. Here's an example of the DTM derived from it. Another similar view from one like I showed you earlier, where you're seeing all the topography derived, and then the DTM triangle file created from that. And I wanted to as I wrap up, I wanted to talk about Trimble's. I mentioned the Ladybug viewing software and how important that kind of street view like real-time information is. But to me, it continues to push towards a web deliverable for that. So Trimble's MX web delivery, being able to send your engineers a web link where they can jump in, view the imagery, which is huge in itself, but then also being able to view the point cloud. And then to take it even a step further, from that street view like view, being able to do some measurements so that, in a sense, you can go acquire all this information, bring it back to the office. You can, kind of with the asterisk small print with the engineer, say, hey, I'm going to hand over what we just acquired, and you can start using that in a preliminary manner. And you got to kind of drive home the preliminary side of it, but they can start kind of doing some initial planning of their engineering while you're deriving the survey. Because from my experiences on the design side, often I would get feedback from, what's your pain point as an engineer, and that as far as survey goes, and they would obviously say that the weight. And so this is a great tool for you to be able to hand them over all the information that's out in the field and let them use it to kind of start an initial piece there. So always have to wrap up with accuracies. Obviously, this is only as good as the survey that you set. There's are you running levels through it? How many times did you how long did you run your base? How many times did you check into your control? I mean, there's a lot that goes into it, but generally speaking, here are some values of what we expect from our systems. Obviously, the terrestrial LiDAR, because it's there's no motion involved, is the tool that we push out there if we're doing like a structural analysis. But generally speaking, with our mobile system, we're getting 5 millimeters. We're getting excellent data sets if we use proper survey control and tie it properly. So with that, Billy, I'll let you jump in and wrap things up, and we can maybe take a few questions.
Yeah, thanks, Rusty.
Billy, you have 5 minutes.
Yep. Great presentation. Got 5 minutes here. Just going to run through this quick summary. Geospatial services are redefining data collection methods industry-wide, as Rusty kind of showed us there. One of the major things is that we're spending less field in the time collecting data, but more time in the office processing data. And for me, as a land surveyor myself, spending less time in the field is keeping those boots on the ground and out of harm's way and out of out of those busy intersections with the mobile mapping system. There's larger demands on the IT infrastructure to support heavy spatial data sets. Computers and storage spaces getting bigger and bigger every day and cheaper coming down. We can handle those data needs. Definitely offering more demand on technicians for more encompassing skill sets, which I feel like that's a great thing coming about in the surveying world. We got all this great technology. Survey, as a land surveyor myself, I feel like we need to tap into our younger generation and get surveyors more involved in this. And I think this new technology is going to start bringing them our way. It's creating new jobs in the entire market segments at breakneck speeds. Data mining and collection, as Rusty was showing you there, definitely saves time on a project and expenses overall, where you know, those budgets and project deadlines are definitely what we hope to meet. So with that, we are excited that we got to present here today with you guys. And if you guys have any questions, Gavin, we'll give it back to you. But there's our contact information. And again, thanks again.
Wonderful presentation. And Rusty, all of those real world examples is, you know, there's people skeptical about the mobile systems, and when they're starting to see more and more real world examples. And I really appreciate that you wrapped up with the accuracy. That's one of the first questions. A quick question for Billy, though. Are you seeing a mix of people buying and renting, leasing these systems, or is it mainly purchase?
There is a lot of rental going on. These systems are definitely in a different price range to get a mobile mapping system. So renting a mobile mapping system to kind of get your feet wet and kind of go out and test it on a project is something that we see people doing. But I think as they get more and more into it and see the benefit and the cost savings of owning a system themselves, we're gonna find more users actually purchasing the system. Okay.
And the other thing was about training. I know that one of the tough parts, as I struggle with it, is the post-processing mobile. There's a bit of an art to it. You know, with POSPAC, you know, you're running your PPK forward and back and then forward again. And then, do you find people, you know, want a little bit of help with that, or do you provide that service for them if that's the tough part?
We do provide that service. We back up, like I said, we back up Halff with our technical support, and definitely we do provide that service as a support to anyone that needs that support with POSPAC as well. And combining that with TVC and moving the data from POSPAC into TVC and then out to those third-party softwares, we can kind of run that workflow with our customers.
So for those unfamiliar with the term TVC, that's Trimble Business Center. It's the office software.
Yeah, that's correct.
Shortcut.
That is.
Oh, yeah, all kinds of different add-ons and modules like other office softwares as well.
Right. Right.
So gentlemen, thank you again. And then you guys, your Trimble shop. So we got to give a plug and a thanks to Trimble for being one of the sponsors of this event as well. Rusty, it'd be really interesting to do a session in a you know, subsequent VCX about the pluses and minuses that you're finding through end use of image-based and LiDAR. They both have pluses and minuses. So
I agree.
Thanks, gentlemen. So
yeah.
we're gonna move on.